that was an example of how to model your building, import it into Preoptima, apply different facade attributes, and then start to play with the material assemblies of those facades, for example, and see what the impact is on carbon. But optioneering can be done across all kinds of building systems with different building forms. So now I want to show you an example where we test different forms against each other and also play with the structural solutions. So we're going to start by going over to our Preoptima interface. This is your home page, and in the top right corner we have Create Project. Once that's loaded, you'll see this map view, and you'll have the ability to start filling out your project details here. So the first thing we're going to do is type in the project name, and we're going to call this Excel test, and you'll see why in a second. We're going to search on the top right for the site location, which is the Excel Centre London, and this is just a made-up site for a car park next to the Excel Centre, which is a well-known location in London. So this is the Excel Centre here, and we're going to put a proposal on this site just here to the right. Okay, we're going to click this outline tool here, and that will give us the ability to draw on a site, and this is just a hypothetical site, so we're going to just be a bit loose with this, but you can be pretty particular about this. When you're finished, just press return and it will close the rectangle or the polygon and allow you to carry on. So we've got a site here. This is where the geometry will be loaded when we import the model. It will come in the middle, and we'll then be able to move it around from there, and I'll show you how to do that. So first thing is the project name. It's provided at a location here based on that site position, and we're going to make up a name for this architect, and we'll make up a client as well. We could also put the project budget into this line. So I'm going to say this is an £80 million budget. The basic wind velocity is 22 meters per second, and we could adjust this to local data, and which you should have on your site, or this value is fine. And this is needed just to assess the wind loads on that structure that's going to be simulated and then measured by Preoptima. So if you want to put a little bit of project data in here, you could, but we're just going to press save for now. Once you've pressed save, your site will go purple, and that means that it's set. You can go back and edit that if you need to, pressing edit, but we're going to go to the next tab, which is compare designs, one down from project details. And when we go to compare designs, we'll be offered up the upload design option here. So this is where we're going to drop in our OBJ file and import. This pop-up gives you the option to upload your own OBJ, or to, at very early stages, just apply a very simple gross area and number of stories, and this will just model a very simple shoebox. But we're all about working with early stage massing here, so you can upload this OBJ and test your actual massing here. That will give you a pop-up, and here are 3 OBJs that we're going to be using for this example. So the first one is option 1, simple block. I'm going to click open here, and this will now upload. And click upload, and that will begin to go. Okay, great. So this has come in nicely here. This is just a really simple box with a core, and you'll see that we're going to get slightly more complex with each new version. So the first thing we're going to do is just fill out this form here, and once we've done that, we will reposition this design to this part of the site. So let's have a look. So the first thing is we want to give this design option a name, and we're going to call this one option 1, and we're going to call this simple block. Because the plan is very simple here, the import has only segmented twice. So we've got 2 blocks. We've got a small core pop-up sitting on top of a much larger office building below. So there are 2 blocks here. So if I click between the 2 blocks, you'll see that they highlight independently of each other. So we can either click them here or we can click them on screen, and that will allow us to attribute characteristics to each block independently or at the same time. and you'll see how that works now. So we're going to work on block 0, which is the main bulk of the massing. And the first option you'll be given is which data set you want to work with. So you can build your own data set, or we have some data sets set up for you. So we have a global version, a UK and a US version, and in beta we have this RIX version 2 for the UK also coming. So I'm going to select Preoptima UK here, and the reference study period is by default 60 years. We want to do an assessment for modules A through to C in this case. Under the next tab, we have previous works, and here we have a simple GIA input for any buildings that will be removed as part of the project. On this project site, it's actually just a big open site, so we can say 0 here. There's nothing to be demolished. On the next tab, we want to apply different story heights to the block, so we want to say how many stories and what height. So we're going to be doing an office building here, and I'm going to push this story height up to about 3.8 meters, and we don't have 9 stories, we're going to have 6 stories. And I just want to, if I do apply to all blocks, it will apply the same characteristics to the top block, which we don't actually want to do here because there aren't 6 stories, there's only 1 story of that. So I'm going to leave that as it is. The use type is not residential, the use type is office, and you can see here drop down for different use classes that we can model within Preoptima. So we are going to apply this to all blocks because we have only 2 blocks in this case, but they are all office. Next, we're going to provide the substructure, and this site is clay soil type. And I'm not going to specify shallow or deep, I'm just going to work with general foundations for this design. You have an opportunity here to include for any basement stories, so I'm going to turn that off and just say there's no basement on this project. If we did want to, we could add the number of stories here up to 3 and the depth of excavation, and that will all be calculated into the dig and then the subsequent substructure design, but we're on 0 for this. Under structure, this is for the superstructure, we have the ability to apply various types from concrete, steel, timber and hybrid. In this case, we're going to work with concrete, and the lateral system is reinforced concrete in this case, but we would also have the option here for a steel braced frame. What I wanted to show you in a moment is how we can option test for different structures. In this case, the default option I want to have at 9 by 9. And this would be quite a common office grid for a very simple building of this type. So 9 by 9 structure. Floor loading here is set to 3 kilonewtons per square meter, and the flabs are not ribbed, they are flat. And the structural sections, we have the default value of 1.15, which is a value of between 1 for fully optimized, which would mean all of the structural sections have been sized based on the specific loading and optimized. If they are fully rationalized, that would mean that we have some redundancy in some of the structural elements, but we have fewer types, and that makes it easier to prefabricate and standardize detailing around. But we're going to go for 1.15, which is the default value. And we can apply this characteristic to all blocks because we want the core to have the same characteristics as the main building. So we're going to apply that to all blocks. Once we've defined our superstructure, we can move on to the facade, which is the next tab. And here you have the option to add wall types and glazing types and to set percentage ratios for those. So you can have a total area of 100%. And with this building, I want to show 2 different facade types. So the first is a plain precast panel, and the second is a precast panel with pattern moldings into its surface. So half of the building will be plain precast and half will be textured precast. So the first thing I want to do is actually, I'm going to set the glazing ratio to 30% because within these panels we have aluminium glazing, and in this case it's going to be triple glazing aluminium frame. So I'm going to set this to 30%, and immediately we can see the total area has dropped to 80. So we could increase this to 70 and get to 100, but half of this value is going to be a different wool type. So we're going to add that now. So add additional wool type here. So the first wool type we need to set, this is a default that's come in. I'm looking for the precast panel with plain features. So yeah, plain precast panel with mineral wool backing and internal lining. So I'm going to select that for the first wool type. And then the second wool type is going to be the same thing, but with a patternation molding into its outer layer. So that's this one, plain precast panel with pattern depth features in mold. So that's got an additional mold that goes into the formwork for this precast type. It's called a form liner. And that's factored into this assembly. And this has the same mineral wool backing and internal lining. Now, because I want to do half and half, I'm going to make this 35 and this 35. So for the total of this block, we have half of the stories will be the plain precast, half will be the pattern precast, and the 30% of glazing will be this triple glazed aluminium system. Once I've selected the glazing type, I can add some external doors. And in this case, I'm just going to keep it simple and leave 4 external doors for the ground floor. This is an incredibly simple block, and I'm not going to make it any more complicated than that. We could then apply these characteristics to all blocks, but then that would add the same glazing ratio, the same facade types to this top pop-up, which actually I don't want to do. So to adjust that, I'm going to go over to block 1. And I'm going to give it the plain precast type, which is this one. And I'm not going to put a second type in, and I'm actually going to have 0% glazing because I'm going to assume that that's just a plant screen. So that can be 100% coverage for that block. And we will have some external doors on this one. I'm going to put 2 external doors in. And again, I'm not pressing apply to all blocks because I've already done the facades for my main block here. So now we've done that, we can proceed to roof. Once we move on to roof, you'll see under the roof types, there's various options that have been preloaded and you can add your own. The paved and green roof options are blue roof types with pedestals and pavers on top, or green roof system applied on top. So I'm actually going to assume green roof, and you have an opportunity here to add some skylights. I'm not going to put any in. It's an office building. I don't think we would have skylights on this block. So 0 for that. In this case, I'm going to apply that to all blocks. So we're going to assume we've got green roof on top of the core and on top of the main roof. When you move on to internal partitions, you have this slider which allows you to go from fully open plan office floor plate to completely cellular office, which would be more old-fashioned, I suppose. For this type of project, I'm going to assume completely open plan. So we're going to slide that all the way to the left. And here we can choose the internal wall system and the internal door types. So the internal wall system, we'll choose a steel stud wall with gypsum sheathing. And we can also choose an internal door type, which we're going to just leave as wooden. Next, you move on to finishes, and we've got some preloaded, but you can add your own. So we're going to add a carpet finish to this floor plate and a ceiling finish of simple plasterboard ceiling. But again, these can be added as assemblies. Then we're going to move on to MEP, and under an MEP you have the ability to define the heating system and the cooling system, and also to input the module by module embodied carbon for your ventilation system, your electrical system and your plumbing systems. I don't have those on this project, so I'm going to leave them blank for now. I'm going to put the heating system in as air source heat pump. There are other options available, air source heat pump here, and the cooling system as chiller. Moving on to operational energy intensity, we can define the energy use intensity per square meter year here. And for this office building, I'm going to put it at around about 100. You have the ability to define the electricity share percentage and also the grid decarbonisation scenario, which in this case I'm going to set as the UK decarbonised grid. Under other, we are adding a little bit of detail on FF&E and external works, and these are very simply percentage allowances for the A1 to A3 modules. So I'm going to leave those at 5%. Before we run the LCA, I just want to go back through some of these fields to make sure they're correct. And actually, I've realized that I didn't apply the geometry correctly to the pop-up core. So I'm going to just flip over to block 1, and here I want to do one story of actually 4 meters in height. So as we go up, you'll see the block grows, but we're going to go about 4 meters. And it's still use type office, and we are going to have the structure of 9 by 9. Now, when you've been back through the menu and you've checked that everything's ready, the first time we save this, we're going to click Save as New. So I'm going to click Save as New here, and we're going to have the ability to name this, which is going to be option 1, simple block. And when I click this, the LCA is going to run for the first time. And now Preoptima goes to work. It's analyzing the form of the building that I've provided it. It's estimating based on the grid the number of columns. It's sizing the floors based on the spans and the structural system selected. And it's going and adding a substructure as well that is proportionate to the structure above. And at the same time, it's wrapping that form in the facade systems and glazing that I've defined. It's adding the roof materials and the internal characteristics of the building also that we've decided on. And for all of those different things, it's sizing them, and then it's doing a material takeoff. So it's producing a full list of materials, applying carbon data to those materials, and then producing whole life carbon analysis. So this has run successfully, and we have a summary of the gross floor area, the costs of the carbon offset, so this is taken from the total carbon produced by this design. We have an embodied carbon number here, an operational carbon number, and a whole life carbon number as well. And you can see a breakdown of those numbers as applied to each of the modules. If we go to elements, you can see which part of the building is using the most carbon, and often this is the case. The floor is going to be the main contributor. It's a huge amount of material that goes into the floor and holding up the building. So that's in at 26% in this case. And then we've got heating system and walls and foundations just after that. So the building mass has landed outside of the site, so we're going to reposition that now. And we're going to do that with the Reposition Design tool. When you click the Reposition Design tool, you'll be taken into a plan view, and we can pick up the massing here and drop it onto the site in the location we want. So I'm just going to put it over here. And what we could also do is just rotate that slightly. Now it's actually kind of fine where it was. But this would allow you to just align it perfectly with your particular position. So that's great, and we can confirm that. That's not going to fundamentally change any of the numbers, but it's great when you're showing your massing in the right site context for it to be in the right place, which looks good. And if you want to toggle the buildings in the surroundings on, you can press this little icon here, and it will put in the building masses as well from the data set. So this isn't a particularly built up site. But that's can be useful when you're showing your designs in context. Now we've got the first option in, we can add the 2 other options I wanted, and we can see what the impact is on those numbers. So to add a new design, we're going to go over to Compare Designs, and we can see our first result is sitting here waiting. That's the one we just ran, and we're going to add a second one now, which is going to be the step mass. So we're going to do Add Design, same process. We're going to upload the second OBJ. Okay, that second massing has come in, and as you can see, this is a slightly more complex form with some steps in the plan as we go around the building. Now, the way I'm orbiting here is clicking the right button on the mouse and just dragging my view around, so that can be really nice, quick way to just sort of look around the model and see what's going on. So, same process here. I'm going to apply all the same attributes to the second design, and then we'll be able to see how the form has impacted the carbon number. Okay, so I've been back through that design, and now this is a new design, so we want to save as new. And this one's going to be called option 2, stepped plan. Press save, and then the process runs again. that's completed, and the building's sitting in the middle of the site, which looks good. We've got a new number here. This is a higher number than the first one, so we can go between them here if we want, and we can see that the previous was 943 embodied carbon, and we've changed slightly to 983 in this case. So this is still a 9x9 concrete grid. And if we want at any point, we can go back to compare designs, and we can see these now side by side. So here you can see the operational embodied whole life carbon numbers side by side, and we can just start to build more of a picture as we add more options for this design. We're going to choose to add a third option now. So this third option will show a stepping form in section. Same process again. We're going to load up our third OBJ. Okay, and here is that stepped form. So this is stepping as you go up the building rather than around the perimeter, stepping in section. So I'm going to do the same thing. I'm going to apply all the different attributes that we discussed, and then I'm going to reposition the block onto the site. Okay, this third option has all the right attributes now, so we're going to save new and run this third LCA test. So this one's option 3, stepped section. Press save, and the LCA will run. This block needs to be repositioned again, so this one's landed slightly in the wrong place. So again, click reposition design, and we can move that one over quickly to this part of the site. So what you'll see is the 3 options sit side by side as you go through them. That's fine. We'll click confirm, and that's it. That option is now saved at the bottom of the menu on the left. And we can see a new embodied carbon and whole life carbon number here. So we can go back to compare designs now, and we can see the 3 options sitting side by side, and this is a really good way to work. This graph here will show you how each option fares under each system type. So for example, option 3 is coming out as the lowest on columns. Option 2 is coming out at the highest on foundations. So that would make sense because the stepped option in plan has more building higher up the building, so it's probably causing larger foundations as a result. So these are the sorts of nuances you can see even just with a couple of simple steps to the form. So hopefully you can see that as you optioneer with your massing, it's going to have an implication on the inherent embodied carbon of your design. We don't have to stop here, we can keep going. So we can go into one of these and we can change any attribute and see that as a parallel option. So perhaps I want to try, if we say stepped option in section, here is actually coming out as the lowest number. So let's go into that and let's see what happens if we change the grid a little bit. So we're going to go into option 3 here. In order to create a new sub option, we just need to trigger the edit, and then when we've changed something, we'll do save as new, and that will create a new option that sits in that chart. So what we want to do is play with the superstructure, and we're going to just see what happens if we increase the grid dimension all the way up to 11 meters in this case. And we'll see how that goes. So we're going to apply that to all blocks, and we're going to click save as new, and this is step section with 11 meter by 9 meters. Press save. And while I'm here, I'm going to do another option for a a steel alternative. So let's have a look at that. We'll do edit design, change this in for steel, and we'll just leave that for the time being on, we'll do the same, 11 by 9. When you flip to steel, you have the opportunity to change the, you can either have reinforced concrete bracing for the lateral stability, or we'll choose steel bracing for this. We're going to apply that to all blocks, and we're going to save as new. So we're going to call this steel. And so we've got 2 additional options on top of the 3 that we modeled. And so when we go over to compare designs, we will see those options have been added. So the step from going from a 9 by 9 to an 11 by 9 has increased the embodied carbon quite substantially by doing that. If we flipped instead to a steel on that looks, with that grid, that would be a more efficient way to do it. And the embodied carbon for this option is coming out at 861. So that's a little exploration of a very simple block massing, 3 different variations of form, and then a couple of sub variations within that. And hopefully you can start to see how every little button that you press and little dial that you tweak will have an implication on your embodied carbon, and it's really great to be able to see a live picture of that. Now I've gone back into that final option, the steel option, and I'm going to just show you how quickly to download the reports. So we can go, we can get the data at any time. We can look at the carbon here. If we go down to carbon tracker, we can see that for each of the options. So you can click through each of the options, and under each of these you can see all the materials have been added for the different systems, and you've got the breakdown module by module of the carbon per square meter. And so from here we can go down to detailed results, and you get a more detailed breakdown other than the summary on the previous page. And this shows you more information about exact data around each of these building elements, where the carbon is being spent, and just a general summary page. From the Compare Designs page, we can download OBJ again if we want to share it with anyone else. We can also download the PDF summary report and an Excel spreadsheet of those detailed results. So let me just show you that now. So perhaps we do it for this final option here. I'm going to download the PDF report. This is just loading. And here it comes. And here we have a snapshot report breaking down the information presented, all of the characteristics of the design that have been considered, and the full material quantities, followed by the lifecycle stages breakdown and some of those charts. What is the embodied versus operational costs, and the whole life carbon results by element, showing element by element breakdown. And we can download that here using this button here. And also let's just look at an example of the spreadsheet. So I'm going to download the XLS button. And here is that spreadsheet. So on the first tab, you have all of the results by element, the summary results by stages, and then you can go to the detailed results page, which has all of the different material elements. It has their kilogram mass as calculated by the model, followed by the carbon emissions per square meter under each module, so A1 to A3, all the way through to D at the end there. Thanks very much for your time. I hope that these examples and workflows will prove useful to you, and that you have ideas about how to use Preoptima on your project successfully. Please get in touch if you have any more questions. Goodbye.